All right, so today we're starting our trig unit. And so please know that we're going to go a little bit more in depth. So I'm going to ask you guys to kind of recall a lot of information, right, from trigonometry. Okay. So we're going to be building what we call the unit circle. Okay. And what the unit circle is, it's basically a circle with radius 1, with a radius of 1, right? Kind of, and we're going to, this is kind of, it's on the coordinate plane, okay? So we're actually going to be able to tell exactly where certain points are on this circle just by using trigonometry to kind of find them. So how we're going to do this is we're actually going to use triangles, okay? And I know that kind of sounds weird, right? But trust me, it ends up working. So just kind of review here, okay? The two triangles that we're really going to focus on are our special right triangles. Okay. We have a 45, 45, 90 triangle, right? And we have a 30, 60, 90 triangle. Okay. So for those of you that don't remember the special right triangles, right, for 45, 45, 90, right, my two side lengths are going to have the exact same value. Let's just call it x. And then if I take either one of them and multiply them by rad 2, that's what's going to give my hypotenuse. For 30, 60, 90, the side opposite the 30 degrees is always the smallest, so we just call it y. Right? Then we found by reflecting this and creating an equilateral triangle, right, that my hypotenuse would be 2y, and my middle side or my other leg would be y rad 3. Okay. Now what we're going to do is, obviously, if I'm looking at this unit circle, okay, each of these points, so for example this point right here, right, each of these points, right, yes, there's no real triangle. It's not like we're laying down the y rad 3. What we're doing is we're essentially going to use the hypotenuse for each of these problems. The only difference is the hypotenuse is 1, okay? So we'll talk about that in just a second. So what I did here is we just created the triangles, right? So we're just assuming that our hypotenuse is 1, right? And then we had to solve in order to find the other missing sides, okay? So if my hypotenuse is 1 in a 45, 45, 90 triangle, right? That means each of this side lengths are rad 2 over 2, okay? Same thing with if I do a 30, 60, 90 triangle, okay? If I do a 30, 60, 90 triangle, my opposite side of the 30 is 1/2. My opposite side of the 60 is rad 3 over 2. All right, and how that kind of helps us is we're actually going to take these triangles and we're going to embed them on the unit circle, okay? So, how this is going to work is this is where we're always going to start. All right, every single time, okay? So if this is a circle with radius 1, right, then the distance from here to this point, right, is 1. And since it's along the x-axis, this coordinate right here would be 1, 0. Okay? So let's just kind of fill out the ones that we already know just by just by going around and putting in the points that are on the axes. Okay? So if I have this point right here, okay, this goes up 1 unit on the y-axis, but it doesn't move anywhere on the x-axis. Okay? Then we go around to this point. Okay? So this is to the left along the x-axis 1 unit. So we actually go -1, and then it doesn't go up or down, so it's -1, 0. And likewise for this point, we don't move anywhere along the x-axis, but we go down 1 unit on the y-axis. Okay? So those are 4 points that we know right there. Okay? Now, let's just kind of talk about degree measures. Okay? We always start here, so we're going to use this part right here as what we call our initial side. Okay? So imagine every single angle that we're going to talk about starts with this side and opens up, right, in a counterclockwise fashion. Every single angle that we're talking about. Okay? So, if I start here and I go nowhere, right, I ended up going 0 degrees. Okay? If I go all the way up to the top and I go right here, right, we know we've gone 90 degrees. Okay? Then if I've gone all the way to the side, I've gone 180 degrees. So I've already opened up this way. And then if I go down to the bottom, right, I went 270 degrees. Right? Or another way of saying it is negative 90 degrees. Because I went 90 degrees in the opposite direction. Okay? Now, we're not going to focus so much on the negative 90 today and kind of that idea. So what we're going to do is we're just going to build this circle. We're going to find all these coordinates based off of essentially these facts. Okay? So our first angle that we're going to be talking about, okay, is if I open up, so which one's greater, or which one's the least? 30, 45, or 60? Which one's the smallest angle? 30, right? So the first one I'm going to do is I'm going to open up to 30 degrees, okay? Now again, so this is kind of where those triangles come into place. So let's just say I projected this point down here, okay? What we just created, this is a 30-degree angle right here, okay? This is a radius of 1, so we essentially have a 30, 60, 90 triangle in here, okay? So if that's a 30, 60, 90 triangle with a radius of 1, right, we know to get to this point up here, I went to the right, rad 3 over 2 units, and then I went up half a unit, which would make this coordinate right here rad 3 over 2 1/2. Okay? So, our first coordinate on the unit circle is rad 3 over 2 and 1/2. Okay? Now, we're going to do the same thing, just we're going to use, instead of 30 now, we're going to use 45. Okay? Again, this is that's 45 degrees opening up this way, which means that if this is 45 degrees, that means what I have is an isosceles right triangle. Okay? Now, the radius of this guy, right, is 1, and so going back to our right triangle, right? So even though this one's facing the other direction now, what I've done is I've opened up, and I've created a triangle, right? This still has the same exact dimensions, okay? Which means this is rad 2 over 2, this is rad 2 over 2, which means I went right rad 2 over 2 and up rad 2 over 2. So that point right here would have the coordinate rad 2 over 2, rad 2 over 2. Okay? So we've got our first half cut, we've got most of our first quadrant done. Okay? So let's look at our last one for this quadrant, which is 60 degrees. Okay? Again, same way that we found the 30 and the 45, we're going to use special right triangles. The only difference is we're now opening up 60 degrees here. Okay? So imagine instead on our other triangle, right? So imagine instead we're now standing here. So what I've got is now 60 degrees here, but I still have a hypotenuse of 1, right? So this is now going to be rad 3 over 2 on this side. This is going to be 1/2. So what I've actually done is I've gone to the right 1/2 and up rad 3 over 2, making this coordinate 1/2 rad 3 over 2. Or essentially, right, the x and y switched on these two. Okay? Okay. So this coordinate is 1/2 rad 3 over 2. Okay? So to build the rest of this guy, it's actually very simple. All I'm going to do is essentially reflect each one of these points. Okay? So if I reflect this point right here, and all I do is, again, I keep it along the, if I reflect it along the y-axis, or across the y-axis, right, I didn't change how high I went, so it still goes up rad 3 over 2, right? But what it did do, hold on, I know it's kind of hard to see. But what ends up happening to my x-coordinate is it's just the opposite. So it's actually negative 1/2 here. And we'll talk about the angles in just a second. Okay? Same thing if I reflect this one over. Okay? It didn't change its height, which is still rad 2 over 2, but now it went the opposite direction with its x-coordinate, so this is negative rad 2 over 2 for its x-coordinate. Understand? Likewise, this would be 1/2 and negative rad 3 over 2. Okay? Now we're essentially going to do the same thing again. We're going to reflect each of these points again, except for we're going to take these ones and we're going to reflect them just down. So now my x-coordinate isn't moving, but my y-coordinate does reflect, which means it becomes negative. Okay? And it's going to be the same thing for each of these. Okay? And then you can think about reflecting either these points down here to get these ones, or these ones across to get them. Either way, right, it's not going to change what those coordinates are. So if I reflect this one and just go down, I reflect along the y, so it's negative 1/2, but this is rad 3 over 2. Okay? And so my coordinates don't change as far as that's concerned. The only values that change are the y's. Okay? So these are our points. So now we have our coordinates for all of these guys. And we'll talk about why we're even doing this in just a second. Okay? So please know that if I'm looking at coordinates, right? So please always remember that if I'm in quadrant 1, it's always positive, positive. If I'm in quadrant 2, okay, it's always negative, positive. If I'm in quadrant 3, negative, negative. And if I'm in quadrant 4, positive, negative. Okay? Any questions so far? All right, so now let's look at the angles. Okay? So, if I went from here to here, I went 30 degrees. Okay? Then I went another 15 degrees. Then I went 30 degrees. Sorry, then I went total of 30 degrees. And then I went another 30. How far do you think it took me to get to this point right here? How far do you think I traveled? I went another 30 degrees. Okay? So, if it's 90 plus 30, this angle measure is 120 degrees. Okay? Another way of thinking about that, okay, is I'm over here at 180 degrees, and to get from 180 up to this point, moving in the negative direction for angles, I went minus 60 degrees, so this gives me to 120 either way. Okay? And I can kind of fill in that same idea. So I went 120, then this is 135, right, and this is 150 degrees. And if I go another 30, this is 210, 225, 240 degrees. Now we're back to 270. Add another 30 gives me 300. Add 15 gives me 315. And then adding another 15 gives me 330. And then if I come back up here to 0, I also get back to 360 degrees. So 0 and 360 degrees are the exact same. And I can keep going over and over and over and over. Okay? I can. And we'll talk about that another time. Okay? But this is just basically building the unit circle. Okay? So let's just talk about trig again. Because again, this is nice. This is a circle with radius 1. Okay? And I've got every single coordinate on this circle. Okay? So, we're going to go back to trig really quick. And I want you to remember, do you guys remember the phrase that you had to learn in trig? To help you remember the trig function or whatever? Anyone remember?
I feel like once you say it, I remember.
What?
Once you say it, I remember.
Right. So remember, so, ka, toa. Okay? And what this means and what this stands for is sine, right? My sine of some angle is equal to the opposite side over the hypotenuse. Cosine is equal to the adjacent side over the hypotenuse. And tangent is equal to the opposite side over the adjacent side. Okay? So how that's going to work, and we're going to look at each one of these really quickly. Okay? If I'm going to look at my 45, 45, 90 degree triangle. Okay? So what each of these guys say is that sine of some angle, call it theta, is equal to the opposite side over the hypotenuse. Remember, it's a ratio. Okay? Cosine of the same angle is equal to the adjacent side over the hypotenuse. And tangent of the same angle is equal to the adjacent side, I cannot write today, over the opposite side. Okay? So let's see what that yields as far as like sine, cosine of angles. Okay? So let's just do the 45, 45, 90 first. Okay? If I wanted to find sine of 45 degrees, okay? How I do that is I stand at either one of these 45 degrees and I look into the triangle. Okay? Now when I look into the triangle, I'm doing opposite side, so that's the side that's over here, over the hypotenuse, which is always going to be 1. Okay? So I know that the opposite side for 45 degrees is rad 2 over 2, and that's going to be over my hypotenuse, which is 1, meaning that this is rad 2 over 2. Interesting. Okay. Let's see if that applies. Same thing for sine of 30 degrees. If I'm looking at sine of 30 degrees, okay, again, what that means is I'm standing inside this triangle, or standing at this point. I'm looking into the triangle. And I'm still, since it's sine, I'm still looking at opposite, which is 1/2, over my hypotenuse, which is 1. So this is still 1/2. Okay? So one thing that I want you to notice, that if sine of 45, sine of 30, right? If we look at what these values equate to, we'll notice that, well, hey, for 45 degrees, these were both ended up being my y values. Okay. So let's look at what happens when we do cosine. Okay. To do cosine of 45 degrees is going to equal rad 2 over 2 over 1 again. Okay? Because it's now the adjacent side. So again, I'm still looking in. And now the adjacent side is rad 2 over 2. Okay? But my hypotenuse is still 1. So cosine of 45 is also going to be rad 2 over 2. But let's look at cosine of 30 degrees now. Okay? Cosine of 30 degrees. So if I'm standing at 30 degrees, I'm looking into the triangle. Okay? My adjacent side is rad 3 over 2. And my hypotenuse is still 1. So this is actually rad 3 over 2. Or, again, looking back at our coordinate at 30 degrees, cosine was the x value. Okay? And so what that actually leads us to find is that since I know that our radius is 1, right? If I think about each one of these coordinates, it's the same thing as cosine of theta, sine of theta. Okay? So each of those coordinates can essentially be thought of as cosine of the angle, sine of the angle. Okay? Now again, we said that this is a radius of 1. Okay? If all I do is expand this thing out, the triangles, remember, right? If they have the same angles, they're proportional. So if r is not equal 1, right? My actual coordinates are r times cosine theta, r times sine theta. But again, I'm not going to have you guys worry about that so far. This is what I want you to kind of remember. Okay? Because this is actually going to help out a lot. Okay? So, let's just do the first couple problems on number over here for examples. Okay? How I do this is sine of 45. If I want to find sine of 45 degrees, okay? Hold on, I gotta have my little degrees symbols in here. If I want to find sine of 45 degrees, I'm going to go to my 45, okay? Remember, this is cosine, sine. Sine of 45 degrees, rad 2 over 2. No calculation required. Cosine, so now we're going to go cosine of 60 degrees. Okay, so here's my 60 degrees. Remember, cosine's my x value. So cosine of 60 degrees was my x coordinate, or 1/2. Now let's just do sine of 225. Again, so sine of 225 is not one that you were ever asked to memorize back in geometry. But let's look at sine of 225. So what I'm going to do is I'm going to go all the way to my 225. And remember, it's cosine sine, so it's actually the y-coordinate, which in this case would be negative rad 2 over 2. So I can use this unit circle to help me evaluate certain trig ratios. Okay? Cosine of 300. Oh, wait. Yeah, cosine of 300. So cosine's the x-coordinate. So I'm going to go here to 300. The x-coordinate is 1/2. So cosine of 300 is also 1/2. So notice how cosine of 60 and cosine of 300 do actually have the same value. Weird how that works. Okay. But then we get to tangent. Okay. So we knew that cosine is the x-coordinate, sine is the y-coordinate. So where does tangent come into play? Okay. Let's go back over here. So let's try and look at, well, okay, what about tangent of 45? Actually, I don't want to use red. Let's go. Let's do orange. That is terrible. That is not visible very well. Okay. Let's do tangent of, and let's look at 30 first. Okay. If I look at tangent of 30, okay, again, I'm standing in my triangle over here at 30, and since tangent is opposite over adjacent, my opposite side is 1/2, and my adjacent side is rad 3 over 2. So, this is 1/2 over rad 3 over 2. Okay? Now, before I go to actually calculate this thing out, I want you to notice that at 30 degrees, 1/2 was my x-coordinate, and rad 3 over 2 was my y-coordinate. Or another way of thinking about this, sorry, I did that wrong. 1/2 was my y-coordinate, rad 3 over 2 is my x-coordinate, and it's the same thing as sine of that angle over cosine of that angle. And so that's where tangent kind of makes its appearance. I'm sorry, I put sine of theta, cosine of theta. It's sine of 30 over cosine of 30. Okay? So another way of thinking about tangent, where's my? So if my x-coordinate is my y-coordinate, and my x-coordinate is cosine of the angle, and my y-coordinate is sine of the angle, then tangent of my angle is equal to sine of my angle over cosine of my angle, right? Or another way of thinking about it as x-coordinate, I keep doing that, sorry, y-coordinate over x-coordinate. So if I want to find tangent of 150, I'm going to go up here to 150, right? And it's going to equal sine of 150 over cosine of 150, which is equal to 1/2 over negative rad 3 over 2. Okay? But I'm not finished there because I need to now simplify. Okay? So tangent of 150 is 1/2 over negative rad 3 over 2, which, right, is the same thing as taking 1/2 and multiplying it by negative 2 over rad 3. Okay? Which will equal negative 2 over 2 rad 3, which is equal to negative 1 over rad 3, which is an indeterminate form. So, or sorry, not, it's an improper form, which means that now I have to multiply this by rad 3 over 3 to get to rationalize the denominator, and I get negative rad 3 over 3 as my final solution. Okay? And that's how we can come up with values for sine, cosine, and tangent, okay, using the unit circle. Any questions on this? Hopefully for some of you guys this was a review, but if not, I get it. Okay, so you do have one assignment today. If you need help, please feel free to speak up and ask questions. As far as other types of values, please know that the unit circle only works for iterations of 30, 45, and 60. Okay? Anything else, it doesn't necessarily work for. But one thing I also want you to think about, so I can use my calculator for the other values, but another thing I want you to think about is if I go all the way around once, I've gone around 360 degrees. So if I go around once and go another 30 degrees, this is the same thing as going 390 degrees. 390 degrees. So I can keep going around the unit circle as many times as I want to. So if you have some ridiculously large angle, I can still find sine, cosine, and tangent of it because it's a circle, which means it comes back to the same point eventually. Okay? All right, any questions on this? All right. I will be posting this video as well as this worksheet right here, or the worksheet. This what we just kind of worked on right here in just a moment.